Hello, I'm Dr. Moumita Biswas. Today I'm discussing about the E module designed based for the chemistry honors student. It is for the chemistry honors student under West Bengal State University. It is basically a practical module, and for the semester 2, and the paper code of this module is CEMA-COR-01P. So this module is designed for the chemistry honors students under the West Bengal State University for semester 2, and it is inorganic chemistry practical paper. So the paper code is CEMA-COR-01P. Now, title of today's topic is estimation of sodium carbonate and sodium bicarbonate in a mixture. So from the topic, it is very clear we are going to estimate sodium carbonate and sodium bicarbonate when they are in a mixture. Now we all know that sodium carbonate and sodium bicarbonate both are base. So it is basically a acid-base titration. So it is a acid-base titration. In our mixture, sodium carbonate and sodium bicarbonate both are present, and we all know that both are base. And we titrate this base with a acid. It is, we titrate this mixture with hydrochloric acid, HCl. Okay, so this work is basically a acid-base titration, and base is here in our mixture. Sodium carbonate and sodium bicarbonate both are base, and we titrate this mixture with a acid which is hydrochloric acid. We need indicator for this titration. Here we use two indicators. One is phenolphthalein indicator, and another one is the methyl orange indicator. So here we use two type of indicator. It is, both are acid-base indicator because it is a acid-base titration. The indicators are phenolphthalein and methyl orange. Okay. So now we look the reaction. What is going on? So we closely look at the reaction. We have a sodium carbonate and sodium bicarbonate mixture. So what is the reaction? So first, sodium carbonate is reacting with the HCl. Okay, so take a look. What is the reaction? Sodium carbonate plus HCl. So in the first step, sodium carbonate reacting with HCl and forms NaCl plus NaHCo3. Okay, so this is the first step reaction. Just look at the balance: 2 sodium here, 2 sodium, 1 chlorine, 1 chlorine, 1 hydrogen, 1 hydrogen, and 1 carbonate, 1 carbonate. So it is a balanced reaction. So this is the first step reaction, and if we look very closely, then we can understand this is a half neutralization reaction because here sodium bicarbonate is formed. So all the hydrogen not formed, here there is no, all the hydrogen is not neutralized. Okay, so it is a half neutralization point. And then this is the first step reaction, and then sodium bicarbonate again reacting with HCl and complete neutralization takes place. Here NaCl plus carbon dioxide form and then water. So here you see complete neutralization takes place. Only salt, carbon dioxide and water. So here there is no, no hydrogen constituting any compound is present. So here complete neutralization takes place. Okay. So sodium carbonate reacting with HCl in two steps. First it forms sodium bicarbonate, and in the second step sodium bicarbonate again reacting with the HCl and complete neutralization takes place. Now for the first step reaction, the end point, for the first step reaction in the end point, pH is nearly equal to 8.3. So for this step we are using the phenolphthalein indicator because this indicator is suitable for this pH. Okay, but for the second step, the end point, at the end point the pH is nearly equal to 4. So here phenolphthalein is not suitable for this pH. Here we use methyl orange. So for the second step we use the methyl orange indicator, and for the first step we use the phenolphthalein indicator. So this is our task. We are going to do the titration. It is a mixer. We take the mixer of sodium carbonate and sodium bicarbonate. Okay, both are base. We are titrating with the standard HCl solution, and these two steps reaction. And for the first step we are using the phenolphthalein indicator, and for the second step we are going to use the methyl orange indicator. And what is happening, what is the color change, we can experience it when we are actually go for the titration. So let's do the titration. Now see, this is a sodium bicarbonate salt. You can see, I hope you see the sodium bicarbonate salt. It is a white powder. Okay, and this is sodium carbonate salt. You can see it is also white powder. Okay, so it is more fine than the sodium carbonate. So these are the two salts, sodium carbonate and sodium bicarbonate. Now we make a mixture of sodium carbonate and sodium bicarbonate salts with a distilled water. So it's a solution of sodium carbonate and sodium bicarbonate making with the distilled water. Okay, so we need this. It is our sample solution, sodium carbonate and sodium bicarbonate, and we are going to estimate the how much sodium carbonate and sodium bicarbonate are present here. Now this is a standard HCl solution. Okay, it is standard N/20 strength HCl solution. Okay, now this is the methyl orange indicator, and here it is the phenolphthalein indicator. This is distilled water, and these are the things we need to do our titration. Now first we fill the burette with the HCl solution. So here it is, we fill the burette with HCl solution. So first we fill the burette with the HCl solution. Okay. Now this is conical flask. This is conical flask. Now we pipette out 25 ml this mixture, sodium carbonate and sodium bicarbonate mixture. Okay. So just we Here we take sodium carbonate and sodium bicarbonate mixture here for pipette out. So we take 25 ml sodium carbonate and sodium bicarbonate mixture. Okay. Then this is the measuring cylinder. With it, we take 25 ml distilled water. Just 25 ml distilled water here. So in conical flask, we have 25 ml we pipette out, 25 ml sodium carbonate and sodium bicarbonate mixture. Then we add 25 ml distilled water. Then we put phenolphthalein indicator, just 2 to 3 drops. And let's see what happened here. It is base, so indicator should indicate, yes, it is base. So we are using phenolphthalein indicator and it gives its color. As it is base, it is pink color. Now let's start the titration. Okay, so it is a base here, sodium carbonate and sodium bicarbonate mixture, and acid here, HCl acid. We take the phenolphthalein indicator and it indicates it's a base because it is a pink color. Now the color will be changed at the end point. Now let's see what's happened. Now start the titration. We dropwise add the HCl and shake it well. And wait for the color change. See what's happened. So the color changes to colorless. Now here's slight pink is there, so we are just, yeah, it's the end point, very much near to the end point. Now yeah, the color is totally changes to colorless. So this is our end point, and we record the burette reading. We record the burette reading. It is 11.9. So we have to remember this reading. It is 11.9. Okay. Now, so this is our, if you remember, this is our first step, that is sodium carbonate reacting with the HCl and form sodium bicarbonate. And the end point, the pH of the end point is nearly equal to 8.3. So we are using the phenolphthalein indicator, and phenolphthalein indicator changes its color in this pH. It changes the pink color to colorless. Okay, it is the end point, and our burette reading show that this is it is 11.9. So we have to remember this reading. This is our V1. Okay. Now now here only bicarbonate is present. That means the bicarbonate which is already present formally, because in our mixture bicarbonate is present, the sodium bicarbonate and the sodium bicarbonate which is formed from the sodium carbonate. So total sodium bicarbonate is present. Okay, so here now sodium bicarbonate which is formed from the sodium carbonate and the sodium bicarbonate which is already present. So total sodium bicarbonate is present here. Okay, so now we again fill the burette. We again fill the burette with HCl solution. Okay, so we again fill the burette with HCl solution. and adjust it properly. Okay, so okay, now we are going to do the second step. That is, here total sodium bicarbonate is present, and for this step we are using the methyl orange indicator, second indicator, and see the color change. What's happened here? It is methyl orange indicator, and again we put 2 to 3 drops of methyl orange indicator, and it gives a yellow color. You can see it's a yellow color. Now start our titration again and see the color change. Methyl orange indicator gives a yellow color in base media. Now we are adding the HCl and it shows some color change at the end point. Okay. So it takes time because it's a total sodium bicarbonate. So total sodium bicarbonate we are estimating. Then we're getting the local color. Local color is coming. So the color is changed. Okay, the yellow to red color. So the color is changed, yellow to red color, and this is our end point of second titration, and the result is 44.6. Okay, so it is our V2, 44.6. So our V1 is the 11.9, if you remember, and the V2 is 44. Yes, it is 44.6. So we have to remember these two readings, and with using these two readings we are going to calculate how much sodium carbonate is present and how much sodium bicarbonate is present. So we have to remember these two readings. The first titration, the reading corresponding to first titration is 11.9, and the second titration reading is 44.6. Okay, so let's go for the calculation. Now go for the calculation. So first we write down our reading, that is V1 is 11.9 ml. We need 11.9 ml HCl solution for this first step, and V2 is 44.6 ml. Okay, so we need, for the second step, we need 44.6 ml of HCl, what we see in the titration. Now, we know that 1000 ml, 1 normal HCl is equivalent to 1000 ml, 1 normal HCl is equivalent to 53 gram sodium carbonate, Na2CO3. Okay. So 1000 ml, 1 normal HCl is equivalent to 53 gram sodium carbonate. Now in our first reading, okay, it is 11.9. Our first reading is 11.9, but we have to see this is the half neutralization point. That is, half of sodium carbonate is neutralized. So for half sodium carbonate neutralization, we need 11.9 ml HCl. So for the complete neutralization, we need 2 times of 11.9 because it is the half neutralization point. So we need the double of 11.9. So for the total sodium carbonate, actually it will be 11.9 into 2. Why into 2? Because it is half neutralization point. We captured the half neutralization point because phenolphthalein indicator is only indicates the half neutralization point. So we have 11.9 for the first step reaction. So for the complete sodium carbonate, it will be double. So 11.9 into 2 ml. Okay, now our HCl, strength of HCl, it is standardized HCl. So strength of HCl is, we are using N by 20. So we are using the N by 20 HCl. Okay, so 11.9 into 2 ml of N by 20 HCl equivalent to, we have to calculate how much sodium carbonate, 53 into 11.9 into 2, okay, divided by 1000 into 20. So atto gram Na2CO3 is present in our mixture. Now we have to calculate it. Okay, I am using the my calculator from my mobile. So for this calculation, okay, so it is 53 into 11.9 into 2. So it is 0.063 gram of sodium carbonate. Okay, so it is 0.063 gram sodium carbonate present, and you remember we take the 20, we pipette out the 25 ml of mixture. So in 25 ml mixture, this amount of sodium carbonate is present. Okay, Na2CO3. This amount of present. Then in 1 liter, that means 1000 ml mixture, how much sodium carbonate is present? Okay, atto gram sodium carbonate is present. Now we calculate again. Okay, it is 2.5. It is 2.523 gram per liter. So in our mixture, 2.523 gram per liter sodium carbonate is present. Okay, so this is how we can calculate how much sodium carbonate is present in sodium carbonate and sodium bicarbonate mixture. Now we have to calculate how much sodium bicarbonate is present. Okay, now in our V2, you see this is the V2. In V2 is corresponding to, this value is corresponding to the sodium bicarbonate which is from sodium carbonate and the sodium bicarbonate which is already present in the mixture. Now we know from the half neutralization point, this is the half neutralization point, this amount of HCl is needed for the half neutralization point. So the sodium bicarbonate which is formed from the sodium carbonate, that is equivalent to this amount of HCl, that is first titer value, this amount of HCl. So if we subtract this from the second value, if we subtract the first titer value from the second value, then we get the sodium bicarbonate which is present in the mixture. Okay, I repeat this thing again because this is the crucial point here. We have sodium bicarbonate which is formed from the sodium carbonate and the sodium bicarbonate which is already present in the mixture. Now both are titrated with the HCl, and total sodium bicarbonate for total sodium bicarbonate we get this reading 44.6. Okay, now first reading is corresponding to the sodium bicarbonate which is formed from the sodium carbonate. If we subtract this reading from the second one, then we get the sodium bicarbonate which is already present in the mixture formally. Okay, so let's do that. Let's do how much sodium bicarbonate is present. Now we know 1000 ml 1 normal HCl equivalent to 84 gram of sodium bicarbonate. Okay, now our reading will be 44.6. This is the total sodium bicarbonate. We subtract it this value, that is the sodium bicarbonate which is formed from the sodium carbonate. Okay, ml. Now we know that we are using N by 20 HCl. Then what will be the sodium bicarbonate for corresponding days? So you have to again calculate it. 84 divided by 1000, 20 into what will be the subtraction? It is 32.7. And then so it is 0.1373 gram of sodium bicarbonate. Okay, I just check this calculation. Is it okay or not? Okay, so it is 0.1373 gram sodium bicarbonate. Now again we are taking the 25 ml of sample solution. So in 25 ml of sample solution, so in 20 again like this, in 25 ml mixture, 0.1373 gram sodium bicarbonate is present. Now in the 1000 ml, that means in 1 liter mixture, how much present? So you can calculate it very easily. It is 5.4. It is 5.49. So the sodium bicarbonate which is present in our sample is 5.49 gram per liter. This amount of sodium bicarbonate present in our mixture. Okay, so you just check the calculation whether it is okay or not. Okay, so this is all about today's topic. This is how we can calculate sodium carbonate and sodium bicarbonate when they are in the mixture. Okay, now I give you a reference. You can get it from the Vogel's Quantitative Chemical Analysis. This is a very popular book of inorganic chemistry, so you can get this everything from there. And I have a very little feedback for you. You can send this feedback directly to my mail ID. My mail ID is Moumita @gmail.com. So you can send your feedback to my mail ID, and if you have any query, you also can query here. Okay. So it's a little feedback for you. Number one, what is acid-base reaction? What is acid-base reaction? Okay. Number two, give the reaction for Na2CO3, that is sodium carbonate, and HCl. Okay. Number three, what is the indicator? What is the indicator you can use for above reaction? Okay. Number four, give the structure and formula of an acid-base indicator. Okay. So this is a very brief feedback, and I hope you enjoy the lecture. Okay, thank you.